Good afternoon. Today we will be discussing the optimal Ethernet cable management for network switches. The introduction to network configuration is understanding the correct way to plug Ethernet cables into a network switch, as well as the proper sequence for activating switch ports. Might seem straightforward, yet the complexity of power distribution and port allocation within these devices warrants a deeper look. The illustration below is of a Ruckus 7150 48-port PoE switch. Power supply constraints. Most switches are equipped with either a single or dual power supply. Importantly, these supplies are generally not capable of supporting full power over Ethernet PoE capabilities simultaneously across all ports. Switches typically organize their data ports into clusters of 8 or 12, aligning with common configurations of 12, 24, or 48 ports. This diagram below illustrates switch port clustering of the Ruckus 7150 48P. The importance of port clusters. Each cluster of ports is connected to a specific section of the switch circuit's board, which is crucial for managing power distribution. For instance, a 24-port switch with a 380-watt power supply will have 3 clusters, each able to draw a third of the total power. This setup ensures that each port can deliver adequate power for standard devices. However, devices requiring more power, like the R650 radio needing 30 watts, necessitates careful planning regarding which cluster they are plugged into. The diagram you see below illustrates the internal circuit boards of a 24-port microtik, and the right-hand picture is a good example of how switch ports are broken up into clusters. Strategic loading of PoE devices. Contrary to intuition, filling ports sequentially from port 1 onwards can lead to power imbalances and operational inefficiencies. A more effective strategy is to plug devices into every other port, example 1, 3, 5, and 7, especially in configurations where higher-end devices are involved. This approach helps distribute the power demand more evenly, ensuring stability and reducing the likelihood of power outages. This diagram below illustrates a common and best practice cabling technique to ensure optimal performance. As you can see, the odd number of ports are your PoE ports, and the even number of ports are your non-PoE ports. Patch panel and switch optimization. Our standard organization involves a 24-port patch panel, followed by a 48-port switch, and another 24-port patch panel. Devices requiring substantial PoE power should be connected in the upper half of the switch, with the lower half reserved for less demanding connections or data drops. This illustration demonstrates a common build style for new construction. Balancing the load. To prevent overheating and prolong the lifespan of the switch, it is crucial to balance the load across available ports. For example, if a switch has 42 PoE-capable devices and 48 ports arranged in 4 clusters, the ideal distribution would be 11 devices in clusters 1 and 2, which is 91.6 load, and 10 devices in cluster 3 and 4, 83% load. This distribution helps maintain operational efficiency and enhances the overall uptime and reliability of the network infrastructure. This picture illustrates balancing port density by spreading out ports on multiple switch port clusters.